crazy stuff.
Crazy stuff.
All right, we're back. We are WEBD6201 in the winter 2020 semester. That's client-side scripting at Durham. And we're week 3, part 2 of our broadcast. We're talking more about ES6, ECMAScript 6, so the latest version of JavaScript. I just want to go back to what we did yesterday a little bit. So yesterday we had this little thing that we were working on. I'm working with the exact same lesson from yesterday. It's lesson 3A. That's also up on GitHub. So just to recap, if you go to Durham Programmer, so github.com/Durham Programmer, then you're going to see that here we have our lesson 3. This is 3. And in here, we have everything you need. So if you weren't here yesterday, or for whatever reason, your stuff didn't quite work like my stuff, then you could come here and start from here, okay? A couple notes about code I share with you guys for next week. You have access to it all. So if I've shared the code with you, consider it, go ahead, easy, free to use. So if I've given you something, you can certainly look at it and use it. The only thing I'd ask is if you're using code that I've shared with you in class on a test or on a lab, just reference it. Say Tom's code. Code share with us in class, and I'm good with that. So, and if you're getting code from somewhere else, there's always a section inside my little labs and assignments and everything else I'm going to give you that says, please reference the code. Make sure if you're unsure if this is too much, it shouldn't be that, shouldn't be all somebody else's code as an example, but if it is, then talk to me and then I'll say if it's okay or not. For the stuff that we're doing with our lab and maybe for the test next week, I don't recommend that there's going to be any need for you to look at other people's code other than mine, chances are. What you don't want to do for next week is please don't look at each other's code online. Like if you share your, up on GitHub and then you take their code, that would be bad. Because then I'm like, well, it's the exact same code. Then I'm going to have to make a decision. Is it like one person copying from the other person? Please don't do that. That would be not beneficial to you or anybody else. So, so try and make it your own. I mean, if you want to get the idea for how things are done, then I think that's what you do with the code. That maybe if you talk to somebody else, like remember I told you that next week, it's going to be more casual. You'll be able to talk to people in class. But it doesn't mean that you're going to say, so can you shoot me that code through Discord? Can you give me that code on Slack or whatever, or WhatsApp or whatever? Can you shoot me that code through email? None of that. Can't do that. That's not going to be allowed. However, if you say, well, here's how I did it. I used document.getElementById. Remember, and what Tom showed us in class? That's okay. Because that's normal. That's like, yeah, I did this. Oh, okay. Right? And then that person can go on. If they still don't know what to do, they can go up on Google and go document.getElementById. And that's okay. That's the process, right? Not every test will allow this freedom, right? But this is the first test, and I want you guys to have the ability to go up online and do some exploration. Sometimes I may ask you to do something that is a little wacky with your labs, but these ones are super straightforward. I mean, I'm literally following everything that we do in class, so there's nothing really outstanding for you to do in this scenario, okay? All right, so last day, so I used this project, and last day what we did was when I ran this thing, so I'm going to press Control backtick here, and if I press light, look at that glitch, light dash server, this is nice, it does this, and we can hover over, we get an event happening, and I have this. And I have this really weird blue thing now that I kind of made happen with code. But our code is getting a little bit insane, and I don't like it. Like when you get scripts, app.js, that kind of looks like it's all over the place like this. It becomes really rather unruly and difficult to maintain. So what I'd like to do now is I want to, in this case, wipe away everything. For the most part. So I want to start just with the window add event listener load. Remember that from a coding perspective, you still will have access to this on GitHub, this whole thing, even if I wipe it away. Let me show you what I'm talking about. Up on GitHub, if I go here and I go to commit, I can actually look at the commit itself. If I click on the commit itself, it'll show you the code and any changes I made for that commit. Like all the code for it when I add this, the pluses are adding, and any green is like things that I've added in, or this is my base. So that's one way to look at it. You can also click on Browse Files, and Browse Files will literally give you all the files from that commit. Notice that it says tree EB, E7, D, something or another, right? If you see this, that means I'm actually looking at this commit. Look at EB, E7, D, C9. That is the commit number, and that's the tree number. If I just click code, that's going to give me the master branch. Master branch means like that's where we are currently, the head of my snapshots, right? So you can always look back and see any of the code that I've shared with you, even if I mess it up. Even if I go in and like wipe everything out and then push up to GitHub, you can always go back to the previous commit and see everything. In fact, you can always revert too. If you ever download this project and revert, you can revert back to the previous version. So what I'm going to do this time around is, and I'll buy one more thing. I'm also recording stuff, so worst case scenario, you can always go back and rebuild everything through the recording if you want to, which is not a bad exercise. All right, so I want to just wipe everything out, and I want to do something similar here, but I want to start structuring our code a little differently. So let's just wipe all this out. So basically, I'm going to have, I need a couple things here, just to start. I need use strict, but inside of my function, right? Let's talk about my function here. So this iffy, I'm going to make I need a start function because you see I'm calling start, right? So let's make a start function. So we'll call it function start. Now, again, as a review, function start, this is the one way of doing it. And then, of course, we can use the other two ways. There's two more ways of declaring functions using making variable notation happen. So I could declare a function that looks like this, remember? Let like, my function is equal to function. I could do this way. That's the other way of doing it. And you'll see this a lot online if you look online and see what this looks like, right? My function is equal to function. And if you hover and see what that is, like why am I getting an issue? It says I'm expecting a semicolon, right? Here, I'm expecting a semicolon somewhere. And of course, it's because I'm using capital L for let. Haha. Capital L is bad. That's a thing. So let my function is equal to function. Well, my function, now you can see it. And look at what it says when I hover over. It says my function colon, and then you see arrow notation. So Visual Studio Code actually shows you what the function would look like with arrow notation, fat arrow notation, instead of without it. We need to talk about fat arrow notation because that's ECMAScript 6. So let's rewrite this thing with fat arrow notation. So if you don't have any parameters, fat arrow notation just does this. It takes away the keyword function, and then you just add a fat arrow with an equal sign and greater than sign. That is equivalent to function. But why would you do this? Well, the reason why you would do this is because you can write it inline. It's like a lambda function in some of the languages. I'm not sure if you guys did lambda functions in Java or C# at this point. But basically what they are is there's ways of returning data in one line. So that's one thing they can do. And we're going to see these things later on in Node.js. So again, this is one way of doing it. Function is equal to this. And that's totally fine. This is totally legal to do this way. And it looks a little funky. If I had two parameters, let's say I've had parameter 1 and param 2. So here's param 1, whatever that is, and here's param 2. I could do that. The old way of doing it, of course, would be just to do this function and take away this, which is looking like something we already know how to do. And of course, you can always do this. Instead of the let statement, you can always say function, my function, which is, they're all equivalent for you. That's all the same. Okay, so no matter which way you write it, you're going to see them in all different ways, but they all mean the same things. Okay? So far we've talked about how to write functions, how to do the difference between let and var in terms of our scoping rules. We've talked about, which is part of ES6. We've also talked about classes. So one of the things I want to do, let's rename this function to main. which is what it should be called right now. Instead of param1 and param2, let's just not call param1 and param2. So what I want to do now from now on, when we code together, right, I want to use start for initialization purposes only. So anything we want to initialize, all of our variables and stuff, we do in start. So we declare variables up here. This is our new coding standard, okay? From now on, from now until the end of semester, when we do stuff with code, we want to try and do it like this. All right, so the first part is in the functional space, we want to declare any kind of functional variable. So declare function variables here. This is where you would declare function variables, okay? And so this would be available, any variables that are global to the function, but not global necessarily to the global namespace. The global namespace is outside the function, outside the IFI out here. You don't want to do anything here. This is if you had more than one closure. This thing here is a closure. And you'd want everything to share that stuff. So that would be up here. But in here, what I want to do with this function is use this thing as our initialization function. All right, we need to talk about some extensions today for Visual Studio. All right, Visual Studio Code. So let's go into the extension manager over here, this extension. I want to talk about some of the stuff I've been using that I want you to grab. So one of them is JS doc, right? So if you type in word JS doc, you can see that that is something that you could download if you really wanted to. Normally use something called document this. Document this. So this is something that I've installed, document this. All right, so I recommend downloading and installing document this. Okay, what this allows you to do is something that looks like this. If I start typing in / and then $, then it does, I can choose between JS doc or document this. You'll only have document this. I want you to use this. If I press tab, I have this capability. And what I can start doing is commenting things like, this, or we do initialization in this function, something like that. We do initialization in this function. So I want to kind of document stuff. So, and we can say we do, we would say variable initialization in this function. So here's variable declaration. Here's variable initialization. All right. So this way, we declare them separately from initializing. And that's kind of a standard way of doing things. We don't want to initialize and declare in the same thing. A lot of times that's a no-no. Okay, so declaring here, initialization here. And then what we want to do is any kind of work that we're going to do is going to be done in main. So I'm going to call main from start. All right, so start is going to be here. That's going to be the first function we get to. It's initializing. Then main is going to start. After initialization is done, we're going to hit main. All right, so main is where all the work is done. So this is, again, I'm just going to go down to document this. Main program entry point is here. Okay. So again, there's two parts, right? This is initialization up here, and then we have our main entry point for the program is here. We can also add some comments like we did before. Does anyone remember how to do template strings? And I talked about this a little bit. We talked about template strings, and I want to do a little bit of like styling for my comments, just a little bit. So when I pump things out, remember what the comments are? Console log, right? Console log. And what do you guys remember? What the template? How to use? How to actually style my console? It's %C. So you go this %C as an example. This says, okay, I need a style, whatever that style is. And then from there, the name of what I'm doing. So I'm going to say initializing variables. So these are when I initialize stuff. And then I can style it with my style options. And I can sit there and say use the same style options. I can say like color, which is kind of like CSS. Color is blue, right? And then I can specify a font size if I want or something else. Okay, it all has to be done inside this second quotation. So I just want to do color blue for now. Okay, and then in here maybe I want to do some of the same things. I'm not making it bigger or anything like that because that's a little bit annoying. So this is where my second part comes in, and this is, instead of initializing, main program body is here. So this is like main program body, whatever that is, okay? And we can make that green. So just to make it something different, so we've gone from one check to the other check, right? So any kind of variable declaration happens out here, right? Okay, curious. If I put a console log up here, right? Do you think I'll ever see my console log? What do you think? Why not? Why no? Why won't it get called? Okay, let's try it. Let's try it out. So I want to put my console here, right? I want to talk about synchronous and asynchronous for a second because we're going to hit that later. So if I put my console log here, and I do something else like variable initialization, so variable declaration, declare variables, we'll say declaring variables, and we'll say the color is, I don't know, we'll make it regular. We won't have a special color. I'm trying to think of a color that we can see, that's not green or blue. Red, you want red? All right. I'm not really happy.
Everything in there good.
What the hell, red?
Doesn't everything in there just happen automatically?
Well, I want to see, let's see what happens, right? So, so we can see what, so I save everything, and then if I go back to here, to my code, into this, you can see that all those things I did are gone now, because I took all that away. And if I inspect, let's inspect the console, here's declaring variables, initialization, and main program. So what happened? How did that happen, right? Well, I hear what you're saying about nothing's calling it, but I think the thing that you have to figure out as well is this. If I have an executable command that's in the main function body, right, this is still a function. And so technically the IFI, because it's being called, and it's being called immediately when I connect my JavaScript file to my index.html, it's immediately being called, then therefore it's going to execute all the executable commands as soon as it finds them. So what's happening is because I put my function start down here, and yet I start doing this, it'll execute this one, and then it'll follow the event listener, because the event listener is going to trigger on its own. It's going to trigger as soon as the page is loaded, right? So technically, what I could have, instead of my window add event listener start, I can just have a call to start at the bottom. Let me show you what I'm talking about. Something that looks like this. Could do that, right? And if I did this, and you're going to say, wait, but don't you have to wait for the window to load? Yes and no. Then talk about this JavaScript, remember? So we're still good, right? And the reason why we're still good is because of this IFI. The IFI itself, because it's invoked immediately, it happens when I get to that line. When I'm done, when that line happens, it invokes itself. It calls itself, right? So technically, we don't really need line 29. However, I'm never feeling good about having a dangling function call like inside of another function call. And it's calling a function that's inside of this function. That is kind of like, ooh, right? It's kind of weird. So I don't like that. So let's just stick with this. Although it's not required, and you could technically call the function itself like this, I highly recommend just leaving it as is, like this. So yes, this would definitely work because it's in a function and it's kind of going through. So knowing this, that's why the declarations worked. Remember we said let h2, and we did it here, and it worked, right? If it was never going to get to that function area, and maybe what we're thinking about is if it was in a classic class, like for example in C# or in Java, put it like in the middle of nowhere in the class, it's not going to do anything. You're going to be like, wait, I don't know what this is, right? But in this case, it's okay. In this case, it works okay. So this executable works because remember that the function itself is actually calling a phantom constructor. You can't see it. And this is actually a constructor function. One thing else we want to do is this thing here can be named, right? This whole thing. Remember that when we were looking at TypeScript, just briefly, we saw that the IFI is also nameable. So if I was to do that, and if I was to take this and say something like way up here, outside of the IIFE itself, like somewhere here, and let's say I called this IIFE, I don't know, app. So if I said let app equal to this, right? Okay, well then, what is app then? We have to talk about console. We have to talk about objects here. So what is app? So if I go back way down here now and I go console.log, right? If I did app, right, which is a thing, well, what do I get? Well, I actually get undefined, and it happens in a weird spot. Why is that? Well, it happens in a weird spot because this is outside the IIFE, which means it doesn't care if the window loads yet. It just executes immediately as it finds it, right? Remember that this is one of the reasons why we use the IIFE. The IIFE gives us structure. The IIFE gives us order, right? We put something outside of the IIFE, bad things can happen, right? It can execute whenever it feels like, right? So that's something that is a thing, right? However, what about if we didn't do this, and I want to get app, the variable app, out? You know, I want to get access to this app on the command line. So what if I went to, so save this, go back out here, and then in here, like actually physically on this command line, I'm just going to zoom in here, I actually type in app and just press enter. Well, you're going to get undefined. App is equal to this, you know, whatever. It's not defined, right? What if I try something else? What if I try, remember I connected person and I also connected student. So what if I tried doing something like that, let, and if I say something like, you know, Tom equal to a new student. Can I do this? And you can see that I can actually physically do this here in the space because I connect the student into my index.html. I connected two things. Remember last day, just before we left, I connected person and student. Let me show you this. So index.html. I have a couple of connections now. One of them is my app.js, which is what we've been using. And then there's person and then student. Person is my superclass. Think about this as an abstract superclass. And student is the concrete class that we're making. We want to make use of student. By the way, there is no abstract class in JavaScript right now. But they're both classes. So if I look at these files, here's person. Remember we just did this with person. And here's student. And we've actually connected these two things to my index.html in order. Order matters, right? And if we did this, because person and student are in the global cache, it's like I've written student and person out here in the wilderness, right? It's in the wilderness. It's out here in the middle of nowhere, right? And that can be everything that I write in those spaces. If I don't kind of encapsulate it with an IIFE, I can get into trouble. I get into trouble with that, right? Because once I've done this, then it's out in the wild. I can make new stuff. I can, like I did here, I went on the command and I can say new student, and I want to call this student Tom, right? I can say Tom's age. Let's use an age, and then Tom's student ID 1, 2, 3, 4, 5, whatever. And I can do this, and it says, okay, cool, Tom is good. And if I go Tom now, you can see Tom is a student, right? There's Tom, right? And I can also say that, well, Tom dot, says hello. I can do that. It says hello, and I can type that in, and I can go in, and it'll actually say Tom says hello. I can also do Tom dot is studying. That's a thing that I can do as well. There you go. So Tom is studying. So it does all the same commands that I normally can do, and I can do it right here in console. So you might say, that's neat, right? But here's the downside of this. If I can do it, and if I expose all my variables on the console like this, what about if there's sensitive information that I might, that I could give access to the user to do some kind of weird call, a login or something else? Yeah.
Where does that Tom object exist? Client or?
Right now it exists physically in my browser cache. Right now.
So just like a client?
Kind of, yeah. So if I refresh the screen, it's gone. However, I just made it, and it exists. It's in memory right now. So it's a memory object, and until I get rid of it, it's always going to be there. That's kind of weird, right? That's bad. And imagine if I could access the code, but anyone could access the code by right-clicking and going show, kind of view source. I can go to the code, click onto it, see my code, and then do some executable thing that logs me into into the server, right? That's why, guys, it's super important that when you're done coding your files, you put your files through a minification process and get rid of all your comments and all that kind of crap. Because once you have anything like that, then it's a security risk. And I don't know if you guys have taken any kind of security at all, application security or anything like that. But basic practices are like this. If it can be modified, someone will do it. You got to, potentially do that. So this is where JavaScript isn't exactly 100% secure. Just not. That's why we make our clients very lightweight, and we don't share any information that's critical on the JavaScript side. For example, when we do forms, and we're going to talk about form validation a little bit today, right? I want to make a form. How do I make it secure, right? Everything's exposed. Once I have access to that form, I can do whatever I want with that form. I could change up the form and swap out the values and do whatever I want to do, right? Because of this. Unless I put it in an IFI. Unless I put it in an IFI. And if I put it in an IFI, it protects everything. However, and I want to just show you this again, there are other patterns we can use. So if I go to typescriptlang.org, and again, this is just a good step for you guys to understand. If I go to the playground, the other module, they have a module pattern that I can use. So let's suppose here I use the keyword module or namespace. So if I say module, let's say my module, I'm going to call this objects. So my objects module. Let's say I make custom objects, and in there I want to make a class. Now I start typing class person like I did before. And in my person, I have a constructor function as an example. And my construction function takes age and name. I do it the other way around. And name is a string. And let's just make it so that name and age are public, because this is TypeScript. We can do really cool shorthand. But take a look at what we get on the right. This is ES6, right? Look, I'm not targeting like an old version of JavaScript. I'm targeting, let's do ES2020. It doesn't matter. It's going to do this. Right? Well, what the heck is this? Look at this, thing going on. Well, this is another way of doing it. So I'm saying this. I'm saying I have a variable called objects. Look at that. It even uses var, guys. It's not even using let here. ES6, right? Converts var. So I have var objects. And then I have this. I have my function, my IFI. Here's my IFI, right? My IFI is actually going to take a variable, and I pass it in. And then what I do with it is anything that I want to expose, I attach to objects. I got to talk about this structure too, which might be confusing to some of you. What I mean by that is if I type in here export class. Then notice how down here it says objects.person is equal to person. All right? And now outside of objects, outside of this IFI, I have access to the person class, like this. Okay, let me go back. Okay, so I want to kind of explain this again. So this didn't work, let app didn't work, but what if instead of doing it this way, right, up in the top I said something like let app. Okay, and then after I did this, I passed in a variable called app. Okay, here's app. So now app gets passed into this function. I'm injecting a variable, so access to this variable. Now this variable is in the global namespace, right? App gets passed in, and on the way out, just like it shows here in my thing, I return. This is what I'm returning here, and if I take this. Right, structure that I have, this is this right here. If I take this structure, and I'm going to talk about this just for a second, and pile it in there, instead of objects, let's call it app. Let's just replace the name app in here. I want to talk about this. This is valid.js. This is not invalid, right? This is totally valid. So I pass in a variable called app. I pass out a variable called app. That's what this means, right? So that's coming out in and then out. After it's been self-executed, right? I'm actually executing with my variable app, which is actually being taken in. This is the actual input right here. This is the call. So I'm calling app, and app is either going to be an undefined thing or it's going to be some kind of object. Curly braces in your mind should just, in your mind, you should say, that's a quick way of making an object with no class. I don't want to make I want to make an actual physical object, instantiate an object with no class. You can, in JavaScript, you can just use curly braces. Remember in regular C# or Java, you would do this, right? My class as the type, right? And then some variable that represents my class, that's of type my class, right? Is equal to new my class. And now my variable is an instance of my class, yeah? Well, in JavaScript, you don't need to go that way. You can just go, my class is equal to curly braces. And if I do that, guess what? It's an empty object. And we'll do that here today. So some stuff we have to talk about. Because, it's modern stuff. We have to talk about it. So if I do this, and let's say I attach something like main, right? Or let's say I have a variable in here that I want to declare. Something that I want to declare up here that's in the declaration area, right, that I talked about. So I declare a variable. Let's call this variable let h2, right? So it's in here. If I say something like this on the bottom, if I go, before I exit, if I say app.h2 is equal to h2, if I did this, right? And then somewhere down the line, I said that h2, in my initialization, I said that, well, h2, right, is equal to a document dot create element. We're going to have problems of type h2, right, just like we've done before. And then I can say h2 dot text content is equal to, let's call this heading 2, right? And what we want to do is we just want to pass this stuff out. So let's follow the logic here. Curious. H2 is declared here, and we just said earlier that, well, you weren't certain that line 8 console.log was even going to execute, but it did, right? That means that H2, this H2, is actually going to be declared, okay? And then start's going to be called, right? And when start's called on load, it's going to do this thing and then do this work. And then somewhere down the line, I'm going to do this. App, which is an object that I'm passing into the function, is going to come back out of the function with a reference to h2. All right. Let's go back to my code. And then, let's type in the keyword app and then press enter. And you can see app.h2 is a thing now. I can do that. App itself, if I just type in app, right, you can see that it actually has an h2 property now. I actually have access to app. It went in and it attached h2. But unfortunately, what happened with app when it did this work, right, it happened in a weird order. It happened in a synchronous order. My start triggered after I attached it. Because I'm using my IFI and I'm doing this, if I want to attach something like this, it has to be done here. So if I took this and I moved it in here, so I said, okay, attach, now that I made app, now that I made h2, attach it to my app, right? And I'll talk about attachment in a second. Now if I go back, you can see that, so I save this, and if I refresh, right? And if I go app.h2, now you can see that h2 is a heading 2. It's an actual thing. I can actually get that information out because I've passed a variable app inside of my IFI, so it goes inside my IFI now from the outside. Remember, it's in the global namespace, right? Here's the global namespace up here, right? Way out here. I made app. So app way outside the IFI, it gets created. That means it's available in my browser cache anytime, anywhere, right? However, unless I do something with it, it's completely undefined, right? Okay, now I pass it into my IFI. So it goes into my IFI. But I don't pass it in here. This is the function declaration. The function declaration takes a parameter. In this case, it's just called app. You can call this parameter anything you want. All right? I'm just saying. Normally we keep the same name, but you can call this. It's a different thing. This is a thing that's outside of my IFI. This is inside my IFI now. This is a local object. And then if I go down here, this is the actual function call. The function call is happening here, and it says it's either a undefined object, or I'm using the double pipe characters, and notice I'm using another kind of parentheses, or it's an object. It's either one thing or the other. And by the way, if you use the double pipe character, you say it kind of looks at it and goes, which one is it? It's either this one or this one. If it's undefined, first it'll take it'll take undefined. If it's an object, and if I fill it in with stuff, it'll make it an object. All right. So it can't do it out here because the order's wrong, but it can definitely do it here. Okay. Let's talk about attachment. Remember, I went back to this TypeScript stuff and I did this. Well, we never declared age as anything, but somehow I have this. The this keyword in JavaScript, right? As soon as I use it, I declare it. So it's kind of like just-in-time declaration. It can only function like this inside of a constructor, which is usually a function within a function. So notice here I have a person that's a constructor. If I translate this back into ECMAScript 5, you'll see what happens. If I go back to ECMAScript 5, the old way of doing it, it looks like this, where I have a function, and inside that function, I declare a variable person, which is this function, right? Function person. And then notice I have this.age. Well, what this is it referring to? Well, it's referring to the person scope, this thing, right? And I'm saying that I'm declaring it without using let, const, or var. Once I say this, and whatever the variable I want to make, for example, age, if I say this age is equal to something, even though I don't have it, I've never declared it, it will self-declare. It will self-declare and initialize. So that's a thing. All right. So when you see this keyword, and for the first time I initialize it, I can do that. So example, here back in my code, app.h2, right? There was no h2 that belonged to the app. I am now attaching it. Let me make another one. We'll call this, I don't know, app.tom. I'm making a variable up, guys. App.tom, we'll make app.tom is equal to whatever, right? So we can call this whatever we want. So now app.h2, I attached it. I attach it by saying this app is an object. You can see if I hover over, app is just an empty object, right? But when I say this empty object has an h2 property, it doesn't exist. But if I assign it, now it does have it. I create the property by assigning the property. And this is where the old style JavaScript object notation, where I kind of create curly braces and I assign an object, it can fool people. It messes you up because you're like, wait, you didn't do the new keyword, you didn't use let, you didn't do any of that stuff. But still, somehow, it declared an object and we were able to store data. But yeah. And this is where people get like a little confused. So let me show you this. So if I go app.tom and I go back out to this and I type in app and I press enter, well, I do that. I have two objects, one of them which is h2 and the other one which is tom that has a value of whatever. When I attach it and I set a value to it, I'm declaring and initializing all at the same time, which is really dangerous. Because if you don't know what it's doing, you're going to be like, wait, that's really weird curly brace notation. I've never seen that before because we haven't talked about it. Actually, guys, what they asked me to do is talk about it day one. And I didn't think that was a really good time to talk about object notation back then. I think it's best to talk about it now, right now that you guys had all this information. And the reason for this is because it can be really confusing. Yeah?
Shouldn't this stuff be hidden because it's in the FE?
No, because I've taken it out of the FE. Look, it goes here, app is out here. I pass it in down here. This is the function call. This weird bracket notation is the function call itself. I'm self-executing.
Why do you want it to come out?
Sometimes we want to expose things, right? For example, let's say there's something I want to expose. I want to have something out. For example, my person class. My person class, I want person class to be exposed. I want it to be outside of my IFE. But I want maybe to create a namespace or some kind of module pattern that I want to use. So I want to attach all other modules to it. Let's say, for example, I want to create an objects module, and I want to say everything that's in my objects module or my class module, call it whatever you like, a utility module, right? I want to create all my classes, person and student and everything. They're all going to be inside this one big module. And the only thing that I want to declare, that I want to expose there, is just those classes. I don't want to expose everything, but you have to go through my utility namespace in order for me to get my mod, to get those classes. Otherwise, anything that's inside there is hidden. So I can do that too. So sometimes we want to expose stuff. So here's another good use case. I'm doing some testing, and I want to actually get the value out, and I don't want to use a console log every single time. So I can attach stuff to my debugger, attach stuff outside of my class that I can expose temporarily, and then I can shut it down after, right? So here, this is like module pattern is what it's called. So module pattern. And I can attach anything I want. So this here is attach objects or properties to the app object. That's what I'm doing. Whenever I do app dot anything, then I attach stuff in this case. And the reason why I can do it like this is because this function requires a parameter called app. The parameter app, by default, when I put it inside, is if it's not undefined, it must be then an object. This is like standard notation to fix this problem, right? And because it's an object like this, then I can attach things to it. Here's another object. Let's make another example, just to further things. So this is a module from outside. Let's make something else. Let's make it so that we're in the global space. We're going to have something else we're going to call object. Let object equal to a new, some curly braces, right? Like this. That's an object too, right? And if I do this object, and I want to attach stuff to this object. Now this is in the global namespace, guys. Global. I want to attach stuff to this object. I'm not passing object in anymore. So let's, up here, I want to say that object dot, we're going to call this, first property. Whatever that first property is, we'll call this some string property, right? And then we'll say that object dot second property, whatever that property is equal to a number 5, right? And you know what? Let's also say that object third property is equal to a function, an anonymous function, right? That takes in a number, right? As an example, and we're going to write it inline like this. And in that function call, what I want to say is, I want to say that that number, right? That function, when it's called, it returns my number multiplied by itself, right? So notice that the function, it takes number, and then it says, whoa, I don't know what this num is. That's a parameter, but then I'm going to try and square the number, right? Because that's like the function call. And you're going to see that this is an issue, right? I can also say that, well, okay, maybe I can say something like, so if you want to see it in all of its glory, then it would look something like something like this, where I say like number, num, is equal to, or times equal to num. Times equal to num. There we go. That's the better way to do it, and I'll return num then. Num. Right? So this returns it, and that returns. I should put return. How about that return? Haha. So return num, or I'll just do this. Whatever you want. So now there's a third property. So I got a first, second, and third property, and then my fourth property. Let's do another one. Object.fourth property. I'm just making these up. Well, that is going to be equal to some kind of array. An array of numbers or array of weird stuff. It'll be all kinds of things. Some kind of name, some kind of age, some kind of other thing, some other kind of array, like funky dog, and then some other kind of data, maybe even another object, or some other numbers, 25.3, I don't know. Right? I'm just putting random numbers in there, okay? So cool. I've got all this random data, right? And it's inside of this object. Okay, what do I see when I go here? So if I type in the keyboard object and I press enter, I get all this. Look, here's my first property. It's some string property. My second property is this. My third property is some kind of function, right? Third property is a function. Fourth property gives me an array, and here's the array. It's an array of length 4, right, with different things. It's not even a contiguous array. It's like an array of junk. Because in JavaScript, you don't have to have the same types in an array. You can put whatever you want in an array. It's like a everything list. That's what JavaScript is, which is terrible. Can you imagine? Right? I put everything in that thing. So this is what you can do. And if you notice, right, when I did all this, that's cool. That tells me what the object is. That's what object is. But I can also do something like this. I can say that, well, object, I want to say that let my number, right, is equal to object dot third property. And I want to pass in my number, which is like 5, right? Okay, and then I can say my number. This should be 25, right? Because I'm just squaring it. Look, it's 25. It actually does a calculation for me because guess what? Third property is actually a function that squares itself. Right? There's my function. Look, my function is this. The third property is actually a pointer to a function, and the function takes a number and it multiplies by itself and returns that number, whatever that thing is. So, yeah. Right? Good? Or do I confuse you yet? Here's another confusing thing. Let's do another one. Let's do object 2, right? Object 2 can actually be written in all of its glory like this. Object 2. Let's just say let object 2. We have to use, because we're using strict object. Otherwise, I wouldn't even have to do that. Object 2 is equal to curly braces. And inside my curly braces, I can define my properties. Here's my first property. I'm going to call it my first property. And I can assign a value to it, like, for example, a value of, some string. And I'm going to comma separate everything now. So comma separate my second property, right? And then I can say, a number, we'll call it 10. And then, I don't know, some third property, my third property, whatever that is, right? Where I return an array of weird values. I don't know, 1, 2, 3, 4, and then, I don't know, some weird thing. Okay, there we go. And I can do that too, right? That's another way of doing it. Okay, so I did it this way, and I also can do it this way. And if I go back out to here, I can just do object 2. And then, boom, I got all this stuff, right? And object 2 is something that has all those things, right? My first property. Second property, yeah.
Why is the use strict not caring about any of that?
Why is the
use strict? Like, it just seems like you're doing like.
Oh no, this is all strict.
Doesn't look like it.
I know. No, it looks like it's not strict, because this is actually a construct in JavaScript. In JavaScript, I'm talking about JavaScript 101. This is ECMAScript 5 we're still talking about now. ECMAScript 5 allowed us to use objects and create objects just like this. I think even ECMAScript 3 allowed us to do it. So if I pass in curly braces at any point, if I say this thing, like let something is equal to curly braces, all of a sudden I've created an empty object. An empty object instance. That's what I've created. With no class. There's no class associated with it at all. Just an empty object instance. And this, my friends, is called JavaScript object notation. I can actually use JavaScript object notation to create any objects that I want in real time without a class. No blueprint whatsoever. And that makes JavaScript super flexible and super dangerous, right? Because I could do whatever I want, pass in any kind of values I want, and that's great. Here's an example of this. What if I had a function that took in an object? Like, okay, so let's do this. So I can say that. Now this is where you're not going to get any code hinting whatsoever. Okay, so I got object 1 and I got object 2. They're different objects. And maybe I have another function up here. I'm going to call this let. This is all in the global namespace. Completely not protected by the IFE. All right? And let's say these objects, I'm going to have this thing called, my object function. We'll call it my object function, which takes in some kind of variable, an object. It takes a variable called an object. Okay, there we go. And what I want to do with this little function is I want to return out, and let's maybe use the function keyword. How about that? Eh? How about use the, is equal to function. All right, so an object, and I want to return out, I'm going to return back this object after messing with it. So I got this, and I want to say that, you know, and let's make them so, instead of my first property, second property, third property, let's make each of these objects have the same pattern. Watch. So this is first property, second property, third property. Let's make this first property, second property, third property. Just follow me for a second. So if I did this, I have no blueprint, right? But I can do something like this. I can say that first property, so I say that an object dot first property, right, is equal to another string, right? Okay, I can do that. So I pass in an object, whatever that object is. This one, doesn't matter. And now because they share the same property names, first property, second property, third property, and this one even has fourth property, but this one doesn't, right? I can pass it in as an object. So I can say something like, okay, cool, what if I passed in my object as that? I can do a function call. I can say my object function and pass in object 2, right, as a property, as a parameter. And then I can say that, let's print it out. Let's make my new object equal to that, right? So I pass it in, and then it returns out, but it returns something with a different string. Yeah, is it really a new object, or am I pointing to the same one? That's the question you should ask yourself. Well, let's try this out. So go back out here, and then let's take a look and see what we got. So we say, okay, well, what's my new object? My new object. Let's print it out, and you can see that my new object, the only thing that's different between my new object and object 2, here, let's go object 2, object 2. My new object and object 2 are exactly the same. Even though my new object was something that received thing. It's not actually receiving anything, it's pointing to this object that I've changed. So whenever we pass an object into a function, we're actually passing by reference. Something to note. But we can pass an object into a function, no problem. It's not making a copy of that function. Unless we make a copy of that function, which we can totally do. There's a way of doing it. Yes?
Is there a way to denote my value when you pass it?
Nope, but there is a way of passing objects, making a copy, like
Okay.
a clone of
Okay.
one object or another. So yeah, why the heck would, like your question was valid, why the heck would we do it this way? This looks completely unstructured, even though we use strict. I mean, this doesn't look very strict at all, but in fact it is, and the reason why it's strict is because it's okay to declare stuff in the global namespace. That's okay. And it's okay to do this because I'm declaring an object and then setting up the properties. Setting up properties is totally, this is the way we do it with, with JavaScript. In fact, if I wanted to add a new property to object 2, I could totally do that. I can go object 2 dot, fifth property and, do that, right? Because these are objects, and we're going to get into more of this later in the course, not now. I just want you to talk, I want to show you JavaScript object notation like this. Well, we see an example of this here in my package.json. Here's my package.json. Look, here's an object. My package.json declares an object, and it has all these properties. And look, this package.json even has an object inside of another object. Right? Here's an object, and then here's an object inside of an object. You see that? Okay, this is super important when it comes to Node.js, MongoDB, and the stuff we're going to be doing in the latter half of the course. Because the way we write records, if you will, in MongoDB, which are really just called documents, that's what they are, is this way, using JavaScript object notation. So JSON, or JavaScript object notation, is almost become, I would say, the de facto standard now over XML. We don't really use XML as much anymore because it's more cumbersome, right? You have to, it uses markup, XML, like markup language, right? Which is weird. JavaScript object notation, like literally you can do this and I can pass data, right? And in fact, a lot of times we get data just like this. Okay, that's how we get it. And we actually use our application programming interface, and I store a document on a database that's a NoSQL database, which you're going to see later on. When I access that database, I get JSON data back. If I get JSON data back, I can convert this into data for an object. Okay? One more thing. We talked about classes, right? And I also want to talk about this. So when I open up these objects, like for example, new object, I open it up. You can see inside there, it has a couple things. So inside this, I have this thing called proto. And it looks like a macro, like underscore, underscore, proto, underscore, underscore, and then colon, and then object with a capital O. Object, capital O, is the super duper duper class called object that exists, same one exists in Java and C#, the object superclass. That's what this is pointing to, right? So if you think about it, if I open the proto up, you can see that I have a bunch of additional information in here about my object superclass, right? By default, I have a toString function that's built in. I can convert anything to string, right? I also want to get the value of function, that's a thing, and then there's a bunch of other things, toLocalString, and I can keep going down this little rabbit hole. And by the way, a lot of this repeats. So this object, this proto, is like the superclass of all objects. That's what this is. Okay, let me go into this one, because this one is an array, right? But guess what? If I go down here, you can see that the prototype is an array. So it's using the array class. That's what this is. And if I go into the prototype that's an array, further down the line, you'll see that this also inherits from prototype object, right? So an array is a object, and you know, I'm using composition here, if you will. So prototype, remember we talked about inheritance. You guys are used to classical inheritance where you have classes and objects. JavaScript doesn't use that. JavaScript uses prototypal inheritance. It's a totally different way of inheriting things. It creates prototypes. And so what I can do is I can create a prototype instance because the object superclass is implied, which means I don't have to go new object. I could do this too. I could do, instead of me doing all this like this, I could say that, and if maybe this might make you feel better. All right, let's make object 3 now, right? So I can say that let object 3 equal to a new object. I could totally do that as well. That's a thing, right? It's an object, the object superclass. That's what I'm using, the object super duper class that all other objects in JavaScript and basically everything else inherits from. And if I did this, then I could say that object 3 dot, and I can have a bunch of stuff. For example, the constructor function. I can also check to see if it has a property, right? I can change the value. I can make it go toString. Those are the built-in, these things here, has own property, is prototype of, property is enumerable, right? toLocalString, toString, and value of. Those are all methods, right? If you will, of type object. That's what's been inherited. And then if I assign something, like if I say object 3, my function, right, is equal to a new function. I don't have to use a new function. And let's just not even use this. Let's use arrow notation just to merely mess you up, right? I can do something like this, where the function says console log, right? I'm a function, right? I can totally do this, right? Just typing it on one line. So I said object 3, this is an object, but object 3 has a function associated with it. And if I was to do this, if I hover over, if I actually print out what object 3 is outside on the console now, go here and go object 3. Well now, object 3 inside of it has something called my function, which is a function that returns console log I'm a function, right? My function, because functions themselves are also prototypes, right? That have the function superclass as their type. So which means I could use the new keyword when I declare a function as well. Like this. I could say that, instead of doing it this way, I could say that, well, my function is a new function. I could use that as a thing, a function. right? So function 3 is object 3 is a new function. I could say that my function, right, is what I want to return. I could declare that what my function is, right, and kind of add things to it, right? So I can say that my function now, so object 3, got to start with that. My function, right, dot some value, right, is equal to, and I can attach it like, I don't know, 5, right? And if I did that, this, and if I go back to this, and if I type in object 3, and go down to my function, open this up. So open this up. It's an anonymous function, right? And it has some value that's 5, right? Can I keep going? Can I keep confusing you? Because each thing, whatever it is, each construct in JavaScript, whatever it is, including variables, are all objects. Everything. So that's where it's similar to Python. So if you've programmed in Python before, everything is an object in Python. Everything but everything. Whatever you create is an object in Python. So too is it in JavaScript in many ways. The only thing is you can't get the prototype of this some value because it's a primitive. However, if it was an array, it would have a prototype, which is the array type. So I could do for the array, I could declare some array, right? I could say like, object 3, let's make a new thing. I can declare my function. Also is going to have some array attached to it, right? Which is really equal to a new array, right? And notice if I do this, it says array, there's three overloads. I could take an array of minimum length. That's one option. I could have, it uses this is a generic of type, that's what it says. A number, array length, and the other one is some kind of return type. I don't know what to return. It'll actually accept a return type. So for me, all I can do right now is say something like, well, my array with a size of 20. I can say array with a size of 20. Okay? So I could say that array is a size of 20. All right? And then if I did this, and if I go back to this, and I type in object 3, and dot my function, dot, some array, right? And get right in there. And you can see I have an array that's 20, that has 20, a length of 20, but it's completely empty. Right? So that's another way of doing arrays in JavaScript as opposed to making square brackets. Notice when I made an array, all I have to do for an array is square brackets, make an empty array. Square brackets with stuff inside of it, add things to the array. Right? Yeah.
So just to double check, the proto is just identifying the inheritance, pretty much. More, yeah.
And if I can also do things like whatever my function is, function.prototype. I can do that too. I can attach stuff that way too. So example, I could do something like this. I could say that object3.prototype, right? If I did prototype, right, dot, now it's not is prototype of. The reason why this won't work right now is because it's not really a function. I wonder if I can do it with function. Object3.myfunction, because my function is a function, dot, can I do this prototype stuff? No, it won't allow me to do it. Because typically what you want to do is you want to create a constructor function like that. But I could attach it to my class. For example, I have a class that's called person, right? And I have a class that's also called student. So what if I said something like student, right? That's a thing, my student class. And I want to access the prototype, dot prototype. Well, unfortunately, because I'm using the new class type, prototype, I can't do this, student.prototype. It won't do it. Like, my new function is equal to some anonymous function, as an example, with a console log, hello. It kind of will probably error out here, right? It probably will error out. Let's see. So if I did this, it shouldn't work. Shouldn't. JavaScript, weird. Never know. Let's try this out. So why am I doing this? Because if I go here and I type in the keyword student, and I type in enter, you can see student actually is a class, right? And also notice that it got cut off. Like it's a lot of details here, and it won't allow it a lot of times to come up. But you can see that it kind of got me into the student type, which is okay, but it doesn't allow me to show other stuff. Like it won't show more, right? Just the way, because I have limitations on what I can do here. However, let's just print it out. So if I say something like console log here, console log student, I want to see what that is, right? Because I can do that too. Then you can see that student here, it can only print out so much stuff, right? It just won't do it all. Okay, just FYI. Okay, so but can it do my new function? Well, the way it would do my new function is if I declare it of type. So if I said let Tom is equal to a new student, it remembers what I did before. Let's just choose this, right? So Tom is a new student, and then if I say Tom dot, remember I had these other things I put in? Well, look, here's my new function. Ha 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 ha. My new function, right? Because I declared my new function there, then I should be able to do this, and it says hello. So actually, I can attach a prototype to an actual class, even though that my new function never existed in the class. I can use function.prototype notation to attach a new thing onto a class. And when you get to this point, guys, when you look at this, this is like, it kind of eliminates the structure that we're hoping for, right? I like structure, but I'm telling you that this can be done. And then what it does is I've kind of, pulled away the curtain, and I said, hey, look at the man behind the curtain now. There's actually the Wizard of Oz, and it's something else is happening on the backside that you don't understand, and that it's doing something like this. Okay, remember, old school way of doing variables is just like this, right? Or doing classes is like this, right? So when I had a function, and let's suppose I say says hello, right? If I did this, it just says hello. You can see it does person.prototype. It says hello. What I'm doing is I'm attaching says hello to the person prototype. That's what I'm doing, right? I can do that with the object prototype too. The object super duper class. I can say object.prototype. And then whatever I want, right? It's pretty crazy, right, is what I'm saying. When you look at it, it's like really powerful because you can do a lot of stuff without actually declaring classes whatsoever. But when you're like, okay, so what's the use case? What do I use this for? Well, you're going to see when we pass stuff in, let's suppose I want to declare a username and password. And then we're going to go do forms in a second. So I have a username and password, okay? And the username and password, and I also have some other information. I have an email address. I have some kind of communication I want to kind of give. I can put all that in an object with curly braces and pass that into a form if I want to, right? So I can do stuff like I would actually pass an object that doesn't even have a blueprint kind of through my application if I really want to. So why did I do all this? Why did I show you all this? It wasn't for confusion. It was for clarification. Because you're going to see this dot and this dot, what it actually does. So let's suppose inside of my object definition, like for example, in my object, I declare an object or a function, and I say this dot equals to something else. That's another way I could do it. I could say something like object 4, right? We'll call it object 4. And I'm going to get rid of this in a second. I'm just typing so you understand, right? So let's suppose I say let object 4. Notice I'm using the other way of doing function declarations in this case, right? Is equal to a new function, right? And my new function, that's function 4, of object 4, I want to say this dot some property, right, is equal to 5, right? So I use the keyword this. What does this refer to? The context, right? So it refers to these curly braces, typically. This dot, okay? What does object 4 give us now that I did that? So if I go back out, what's the expectation if I put in object 4? So I say object 4, and if I press enter, you can see that object 4 is a function, and it has some property of 5, right? That's what object 4 is. So then I should be able to do something like, if I go back to the console, object 4 dot some property. That's what we're saying. Is this possible? And press enter. And the answer is Not always. Yes, you had a question?
What is this using? Let or
No.
nothing?
No. It's attaching. I'm creating a property as opposed to a variable. So whenever I do this dot in a object context, and this is where I have a constructor type. For example, this constructor notation we saw up here. So this stuff, right? I have an iffy, and inside the iffy I have this structure where I have a function inside of a function. And notice that this function itself is another iffy. Look at that. There's an iffy right there. And there's also this other iffy out here, right? The iffy on the outside, this iffy on the outside, this one right here from line 3 to line 14, that's the module. That's the closure. That's the namespace. Call it whatever you like. Package in Java, right? And then this iffy right here defines the class person. That's this iffy, right? And this function is the constructor function of that person class. They have the same name typically, right? And then I'm adding to the person prototype whatever kind of function I want. Okay, so that's kind of how it's done. And I wanted to show you this in TypeScript because we're going to see code like this, but actually in the background it's doing this. That's what's really happening, right? This stuff. All right, now I want to protect. I want to clean that stuff we just did. I want to wipe that from your mind, and I want to tell you for a second with my magic wand that I want you to forget what I just said. Okay, don't ever use that right now. I just want to tell you that it's there. We can use it. It's very powerful, and we're going to see it later on in this course. But for now, let's make simple structures with JavaScript. Simple structures that we're going to be using throughout the next little while. And we're going to use the class keyword because this is the difference between ECMAScript 6 and ECMAScript 5. ECMAScript 5 uses this notation here. This is the old way of doing things. And this is what this week was supposed to be about. This week was all around how do I have ECMAScript 5, what new things have been added to ECMAScript 6. We have some new things. We talked about let const and the arrow functions, plus some other things, some other little functions that have been added, right? But for the most part, it clarifies or it revamps what this looks like to turn it into something that looks like this. Now, here's something that it doesn't have. There is no export keyword that does this. The export keyword actually does something totally different. And that's something called a module pattern that we're going to be seeing as we approach Node.js. However, we can still use an iffy like this and define a variable called objects that we can hide our classes in. Right now I have two classes, a person class and a student class that are attached to my file. And I want to use those things, but I want to put them inside of an iffy, the same iffy, but in different places. Let me explain this. So let's clean this up. I just did this for demonstration purposes, not because this makes you happy. This shouldn't make you happy. This stuff, and you said it didn't make you happy. You're like, wait, how does this make sense? It doesn't. For regular programmers who don't program in JavaScript, this wouldn't make sense. But it exists. It's there physically. That pattern works. All right. So what I want to do is I want to go back into the person class, and I want to add an iffy around it. Okay, so remember what the iffy looks like. I can do this. So let's make the iffy. So the iffy would look like this. First, we declare at the person level, we declare a variable that's going to be objects. So we'll say let objects. Yeah? And then we make the iffy pattern. So this is something you should be very familiar with at this point because we've talked about it many, many times, right? But instead of calling itself inside here, we want to pass in objects. We want to take in a variable called objects, and we want to say that objects is equal to nothing, right? Or objects is equal to some kind of object, right? Okay, we want to do this. And then inside of here, right, inside of here, I want to put in my class person, this. So I want to take this, and I'll put it in here, right? And my class person now sits inside of my iffy. It's all protected. And now you're not going to be able to see my person class at all, unless I go down here, and I say something like objects.person, is equal to person. Now it's exposed. So this line right here attaches the class person to the objects module, or we'll call it namespace. Okay? So that's what this does. Person's been attached. Do you see this? So here's my object. I declared it up here. I passed it in through here because my function takes objects as a thing, passes it in, declares the person, does all the work. Then down at the bottom, I attach my person, which I've defined here, as something that I'm going to expose through objects. Now the way I can declare Tom as a person would have to be like this. Let Tom is equal to a new objects.person, because person is inside of the namespace objects, which I'm just creating. Okay? I need to do this because this is how we work across multiple files nicely. Okay? And we can protect everything so nothing's exposed unless we want to expose it. Okay? So now I did this, but now we need to do the same thing for student, because student, that's no good. So we're going to do the same thing, right? We're going to create the FE, but now we don't have to declare anything because it's already been declared in the cache. Objects is already there, right? So we can just use it. So we can say that function, IFE. So here's my IFE pattern, right? Remember that first we do the IFE pattern to make it easy. And then after we make the IFE pattern, we pass in objects here. And in the bottom we say objects double pipe, which means or objects is equal to this, right? And then we take this, put it here, and we take all the class, the student class, and cut it and move it into here. And this time we just do the same thing. We say, well, our objects namespace dot student is equal to student. And you're going to say, well, student never existed, but now it does because we're assigning it. We're making it into a property. So objects has a property called student. That's what we're saying. And that's why I had to do all this, because then you wouldn't have understood what the heck this means. But now hopefully you do. It's clear as mud. I don't know. Maybe. All right, let's see if this works. So, yeah. All right, so we've still attached everything, but now if I want to declare a type of Tom, like I want to make this thing here, let's say that inside of my start, so inside of my H2, so in the declaration area, I want to make Tom happen. I want to say let Tom, right? Tom, this is the thing. And then inside my start function, this is a real thing now. I say that I want to make a new thing called Tom. Tom is equal to a new, and I start typing the word objects dot, and I want to type that as a new student. Now I'm not getting code hinting, but that's okay. And I know as a new student, I know this is the problem. As a new student, I want to have name and age and a student ID. So I pass in name and then age as an example, which is, let's say 40, and a student ID, which is 1, 2, 3, 4, 5, 6, right? And then I want to say that Tom dot says hello. I'm not getting any code hinting. And then Tom dot is studying. That's what I want to do, this. And notice that I had to use objects because object itself was part of my person class. So objects. Object is it's kind of like the upper level, the namespace, right? And then because students extends this person, I have to be careful because this doesn't make any sense. Does it make sense? No, I have to put in objects.person. I need to do that. I got to be explicit like this, because if I don't, what ends up happening is that, well, it doesn't know what kind of person. Where's the person class coming from? There is no person class. It's objects.person. Although it doesn't really matter. Let's see if that works. And then if I go back out here, we should be able to get everything. Oh, look, it does. It says it already. Ha ha ha. There. You see that? Now, what do I see on the outside? What do I see exposed outside of my class? I can see the word objects, and if I go dot, you can see dot person or dot student. Those are the only two things I have, but both are attached to my objects namespace. I've put them across different files. I've split them across different files. right? But both those two files, they expose those two objects. Now, the bad thing about all this is I'm not getting any code hinting. And the reason I'm not getting any code hinting is because, you know, there's just not anything like that for JavaScript, right? We don't get that. It's a bad thing. I could make it like, I can use document this to help me, but the problem with it is I might get code hinting. Here's where I could get code hinting, okay? And I'm going to talk about this so that we're good, we're clear. The reason why I'm not getting any code hinting in my my app.js for Tom is because I've declared Tom as type any out here. However, if I brought Tom, instead of bringing him out there, if I made Tom, if I use let down here, now if I hover over it, you can see that Tom is still of type any because it doesn't know what type objects is. So how do we remedy this, right? How do I help with this kind of stuff? We're going to use ECMAScript 6 for this. So ECMAScript 6 has a module pattern, right? That's a little bit different than what we've seen before. Okay, so right now this is the old module pattern that I'm showing you. Remember, we're talking about the differences today between ECMAScript 5 and ECMAScript 6. I'm still using ECMAScript 5 module pattern. This is the module pattern from before. Now I want to use ECMAScript 6 module pattern. ECMAScript 6 module pattern allows me to do things a couple of different ways. One, I can require a particular object. I can import something. So, and a good example of this, at the top of my code, right, where I have my use strict, I could say that objects, right, I could say that is equal to imports, and then I could use an import statement where I kind of specify what I'm importing. Notice that it actually detects Bootstrap and jQuery and all that stuff, right? I can do this, right? Because it uses Bootstrap, jQuery, and Popper.js uses ECMAScript 6 module patterns. So they appear to be objects. But I could do something like, well, I want to import /person. I want to import person as an example, and I could say that, and if I hover over import, it says expression expected, right? I want to do this. That's what I want to do. I want to import this thing and assign it to objects. Object is still any, right? But the problem with the import statement is that usually what you want to do is you want to put this thing here. You want to say that you can use import, you know, I'll say something like person, right? This is what I want. This is module. This is a thing, you know, from, and then I can put in where it's going to be, which is /person. And this is a great pattern. It would be nice if I could do this, right? But I can't do this right now because I haven't set up the ECMAScript 6 module pattern inside of my files. This is how I'd like to do it, right? This is how I'd like to do it. What's a quick fix for this? And it says, well, we'll just remove it, right? It doesn't understand what this is, right? So let's take a look at the ECMAScript 6 module pattern. So if I say that, if I want to look at ES6, we can look it up, modules, ES6 modules. And how do I do that? It actually shows you, this is exploring ES6. It talks about how to do this. So here's a couple of, I'm just going to zoom in here so you can see. Here's an example. It's all over the place, all over the website, all over the web, I mean. So here's a file called lib.js, and I use the export keyword. Here's my export keyword for different functions I want to export. And then in my main, I want to import whatever I want from a particular file. That's how I do it. And that's it. Guys, this is a nice thing if I could do it this way. I don't have to worry about attaching it to my index.html. I don't have to do anything. I would still attach it to my index.html for you if I was you, just from a backwards compatibility perspective. But this would be a better way of doing it, right? Export. So I export whatever I want. Export, export, export. Okay. However, this does not put it inside some kind of IFI or something like that. This doesn't do that, right? So here, import star means import everything as lib from whatever that file is, right? I could also have a default export. I could say that export default, right? Export default, and then I can have some kind of function, right? So that has stuff inside of it, right? Because this function itself will be the thing that I'm importing. That's kind of what I want. I want kind of this pattern, right? Or I can get a class, right? That's things I can do. And it says browser scripts versus modules. So script, I could definitely use a script element. Modules would be script type is equal to module. I have to specify that the type is module in my index.html. That's the thing that I have to do, right? Okay, so that's kind of the way it's done. And it talks about modules in old JavaScript, in ECMAScript 6, in ECMAScript 5, how it's done with CommonJS was what I was using, right? The CommonJS pattern. By the way, it doesn't matter where you look. If you want to look at understanding modules in ECMAScript 6, we can totally look at that. However, I want to tell you that this is an advanced topic, right? We're going to cover again later. So please, it's there for you. It gives us better code hinting, but I'm talking about it today. Yes, it's part of ECMAScript 6, but it's very involved. For me to set this up is not an easy way of doing it, and a lot of times what we need to use is we need to use some kind of module loader, and I don't want to do that. All right, because if I start using a module loader pattern, then you're going to see some other weird side effects. So you have to learn how to use the module loader itself. And module loaders, if I was to actually look and see what that is, your module loader. The most common one is called Webpack. So let's take a look at Webpack for a second, webpack.js.org. Here it is. So what it does, instead of doing things the way we're doing it, it takes all of your JS files and other things, even your CSS, and instead of you linking them the way we do in our index.html page, you don't have to do that anymore. It's an extra application that you need to learn how to configure. And what it does is it links everything together for you. And it creates almost like a namespace that you can access through the module loader. So it's kind of like a bundler and a module loader all in one. It bundles everything together, and then you get these assets you can access later. Really neat. And for professional websites, I'm sorry to tell you this, guys. Remember, we're scratching the surface of where we're at right now. When it comes to JavaScript, we're still at the beginner level. This, I'm sorry to tell you, is an advanced topic, right? There is just no easy way to do this, right? And using the some kind of bundler and a process like this, AngularJS, like front-end frameworks, professional front-end frameworks like AngularJS and React.js use some kind of module kind of bundler and loader, and this is the most common one, Webpack. Okay? Modules. So for us, what I want to do, right, for us, when we split across files for now, is yes, something like this does exist. It does exist, but for now, as we're learning still things, we want to kind of stick to our old module pattern for now, because either this or this still doesn't give us any code hinting. So going back to why I like TypeScript. We talked about TypeScript this week because I'm like, hey, TypeScript is kind of like, JavaScript on steroids, gives you extra stuff, blah, blah. TypeScript gives you code hinting everywhere. In fact, we're going to be using TypeScript, just the library modules for TypeScript, to give us code hinting for jQuery. Because without code hinting from jQuery, next week, after the test, not next week, but the week after when we start getting into jQuery, when you guys start doing jQuery, you'll have zero code hinting. You'll be like, wait, what's that thing in jQuery again? What's that method in jQuery? It's a library. You don't know. jQuery, just to give you a hint, starts like this. It starts like this. Hey, jQuery, do whatever I'm going to do. Do Ajax, right, as an example. And it does Ajax. And jQuery literally uses the $sign. The $sign is actually its entry point. Hey, jQuery, do this. Hey, jQuery, find this. Hey, jQuery, fix this. That's how it works. So whenever you see the $sign, it does it. Now, the great thing about Visual Studio Code is Visual Studio Code already has the jQuery, some parts of the jQuery type definition library built into it. And for most common libraries, it's good, right? But there's going to be some libraries that we download and install that, for example, Node, that VS Code doesn't have all of the functionality built in. It just doesn't understand everything. And you can't get any code hinting or code coloring, right? And guys, we want code coloring and code hinting, right, when we're programming, because I don't know about you, but I have no time to make mistakes. I don't want to look up documentation a lot of times. I want the documentation to tell me what to do, right? So that's how it works. All right, so recap. We talked about how to organize our code a little bit differently and how to split across different files. And in fact, not only how to split across different files, but to create a namespace where we can safely put files and only expose those files that we attach to the namespace by using this pattern, right? So I can attach whatever files or properties I want. And remember, the namespace itself is just a big object. So the object's namespace is a big object. That's all it is, right? The one thing that it doesn't do is give me code hinting. And I can try and get more code hinting. For example, I could use document this, right? So I could do something like, notice it gives me some extra stuff. I could say something like, this is the student class, as an example. And then let's see what it does. If I did this and saved it, and if I go back to app.js, and if I hover over Tom, I'd want to see that, hey, this is the student class. If I hover here, it's not. Let's see if I can do the constructor too. Maybe the constructor will help. If I do something like go to the constructor, and if I go document this, right? It tells me all the variable types of the constructor, which is kind of cool. These are all the parameters. Document this literally does it detects all the parameters of your functions and documents your stuff for you, right? Which is totally cool, man. It's awesome. So if I press save here, and then hopefully when I go back to my app.js, I hover over, no. I'd like to, but the answer is no. Now, there are ways of doing it, and I could include TypeScript definition files without using TypeScript, right? I could do that. And I can do that by defining a person.d.ts file, okay, to help me. So let's say, for example, I wanted to make some type definition files for my student, let's just say, right? So what I could do, and I can try this, is I can make a new file. You can try this too. We're not going outside of the course code. You're not going to get in trouble by other people to know how to do this, okay? And then you're going to create a file called student.d.ts, all right? And if I create this thing, right, what I want to do is in my student.d.ts, it's my type definition file, right? So again, if you want to know how to do this, if I go to TypeScript and I go to documentation, right? And if I go to my handbook, here's my declaration files. It's an introduction on how to do it, right? So it talks about how to make type declaration files. That's what it is. So structures, here's by example. I want to make global variables. I want to make classes. And here's an example of how to do, how to declare my class, right? So basically what I'm writing is the class declaration like this, like in TypeScript way. And if I do this, right, because it's a d.ts file, right, I can do this, declare class, person, or student. I can create the constructor and anything else. I don't do any of the, do any of the definitions, I just declare. So I have to use the declare keyword. So example would be, if I go here and go declare student, I think it's class student, and then I want to say that class student is going to have a constructor. That constructor is going to take three things: a name, which is a string, an age, which is a number, and a student ID, which is a string, right? That's the constructor. Notice, just like here in my type declaration, I'm not defining what's happening in the constructor. I'm just telling things that, hey, this is part of my class student. And also my class student has an is studying method. So just like here, where we have is studying, a greeting, right? I can say that is studying is a method that returns void. Okay, cool. That's my declaration for my class student. Okay, watch. Now what happens when I go back to my app? Do I get any code hinting? Sometimes, by the way, I have to close this down and start up it. But if I hover over it, what I'm hoping to do is my objects.student, I'm hoping to get a declaration for this, right? The problem is that I have a module that's my students under. If I take the module away, let me just take the module away for a second, right? Actually, if I do, you're going to get code hinting. But this is the way we do it. We declare the type, student.d.ts, and we do something like this. We can also declare module objects. So I can say, I think that's possible. I can say declare module objects. And inside module objects, I can put this class, right? I can do one of these. Let's see if that would work. I think so. I think this will probably do it, right? And guys, the reason why I don't need to do this normally is because I write everything in TypeScript and it transpiles, right? So I don't normally do this. But let's see what this does. If I save this and go back to my app.js, does it do it for me? And no, it doesn't, right? Because it doesn't declare this. It doesn't see this as objects dot. I wonder if I do it up here, objects dot student. See, yeah. So it doesn't even see it right now because of the way the files are separated. But this is the way we would do it. We would declare stuff about the class, and this is what your jQuery does. jQuery.d.ts, it declares all the methods of type jQuery, and then what you can do is you can use those methods because they've got declarations. They actually kind of define how jQuery or any other library works. Okay? I guess I probably can put extends. If I want to go further, I can extend, kind of person, my person class, and it would be like objects, object.person. I could do this. And then I could declare my other thing too. I could say that my class, let's declare the other one, just because we're doing it, right? And instead of calling this student, this thing here, let's rename this thing. Let's, since we're not doing anything anyway, I'm just going to rename. We'll call this objects, objects.d.ts. There we go, just cuz. And I'll declare not just the student class, but also the person class. So we'll say person, right? Doesn't extend anything. And then we'll have the constructor as name and age. And then instead of is studying, this is says hello, which returns void. Okay, so that kind of does the entire declaration. I'm just talking about the parts of the class, but not actually doing anything. So then hopefully what you get is when you go to your app.js, as an example, when I start looking at what I'm hoping is that when I hover over objects or students, instead of getting nothing, then I get some kind of code hinting. I should be able to do something like objects, again, dot, and then get some code hinting, and of course I don't. Right? So that's what I'm hoping. We're going to get there. But let's keep that file there as reference, okay? Because it makes sense. Like, guys, I'm telling you, this is the better way to do it, right? It's just that we can't do it right now. Okay, questions about classes, objects, and modules we're using here, again, for an example, I'm going to put this up on GitHub for you guys. If you look at the student class and the person class, both things are split over different places. Yeah, and we want to use this. Go. Tell me.
Huh?
Tell me. Yeah, what's your question?
Oh, so why are you putting them in these there and then exposing them?
Because then it's but it's the same. I'm kind of attaching them to the same object, right?
You're hiding them and then exposing them.
Because it's the class, right? So, but I want to put it inside. I want to compartmentalize my classes instead of a namespace. So I'm organizing my classes. You're right. I mean, I could put them on, and I did that earlier. We had them in the global namespace, right? If I don't want to expose them, I just have to take away this line. That takes away the exposure. This basically attaches the person class to something that I've created called objects.person, where person is just a reference, a pointer to the person class, where objects is the namespace. I know it's funky to look at when you look at this and you're like, wait, what does this mean? Remember, it's just like this dot, whatever property is equal to whatever value. And I create the property as I attach it, as I declare it. It's all one. There's no lets, there's no consts, there's no vars, right? That's just the way it works. Is that a question?
At the end of the iffy, could you very quickly go over again what it means by like object or?
Yes. Yeah. So if I make another iffy, right, and I'll make it down here somewhere. It doesn't matter, right? So make another iffy, and the iffies look like this: function, right, and then the curly braces. This is actually a function, right? So without the other things, without this and this, right? If my function and my function had a name, right now the function, this is an anonymous function, right? But let's suppose my function had a name something, right? And if I pass in a parameter called param, right? I need the parameter for my function to go. If you want to pass in a parameter, it needs param, right? Well, there is no parameter right now, right? But if I was going to call the function, if I said something, if this function was called let my function is equal to this, right? Then whenever I call my function, if I go my function and then I open it up, it looks for a parameter, right? Well, when you make an iffy and you do this, right? And then you do this part, these new sets of parentheses is the caller. It's like doing call this function. So I'm calling it and passing in a parameter, like param. I don't have param, so we can declare it, let param, right?
Okay.
So let's say my param was equal to 5, right? Well, if param's equal to 5, and I call this function, which is an iffy, and I pass in param, then I'm passing 5 into the iffy.
Okay.
Make sense? So what I'm saying is, this is this, but what I want to do is, I'm going to pass in param, whatever param ends up being. Or if param's undefined, which it will be, then let's make param equal to an object, right? That's what this is. So now,
Okay.
let's suppose I had some kind of value here, like, let my value equals to 5, right? And I want to get my value out of the iffy. Then what I got to do is I got to say that param is my way out. I can say that param dot, and then I can make a name, whatever name I want. I usually call it the same name as my value. I could call it my value, or I could call it Tom, right? It doesn't matter. If param.tom is equal to my value, I'm making a reference between my value and this thing that I just made called Tom. Typically, we don't do that. We call it my value, right? And so what happens is now param.myValue is equal to 5. It comes out. So it goes in through here. It's required here, because that's the actual function that requires a parameter. So it goes in through here, it requires that, and then it goes out this way. Thank you. There is no return statement, right? There doesn't need to be a return statement. But we're using objects because param is an object. It is an object, right? So when I do this, then all I'm doing is attaching it this way. Again, I know it's clear as mud. You're looking at it going like, I don't get that, right? Yeah, it's not just you. I can see it in your face. You don't get it, right? But the reason why you don't get it is because I can, when I make a function, or when I make an object, like my object, and I make it equal to this is like me doing, I don't know, my object dot value is equal to 5, right? And you're like, wait, where does value come from? There is no value. Well, once I do this, there is. I just made it, which is what I'm doing here. There is no my value. My value doesn't exist on param. But now when I do this is the value that I'm assigning to this. Now there is. And since there is, and I've passed it in, and it's over here, because it's outside, I've attached my value to this param up here. And now I can get it out, and I can do something with it. That's how it works.
Okay.
Yeah. You got to see it a couple more times in order for you to understand it. Once you see it more often, you'll understand the pattern. It just, when you first see it, it's like, wait, that makes no sense for normal programmers to program in C# or Java. It makes no sense. But actually, if you do a little bit of it, it does make sense. Questions around, is this going to be on the test next week? No. We'll not put this crazy stuff on the test. However, what I might do is I might make you split across files with everything exposed. That's normal. No module path, right? And again, the key to splitting across files, which I will review on Monday, the only thing you need to do is just attach it to your index.html. As long as you attach something to your index.html and you do it in order, anything you do in order, anything you do at the top will be available to stuff at the bottom. Okay, that's all. Code hinting wise, you won't get code hinting though. There will be no code hinting available. Okay, because the only time you get code hinting is if you're doing something in the same file typically. All right, that's it for me, guys. Thank you so much. I'm going to put this up on GitHub. I will stop recording now.